Welcome to Math Challenge 400. Now in Math Challenge 400, we are given a circle inside a rectangle. A circle inside a rectangle, and the circle is not symmetrically placed. That means the center of the circle is not the intersection of the diagonals of the rectangle. So the center of the circle is not the center of the rectangle. We have got a circle, and from the vertices tangents are drawn. One tangent 23 units in length, another tangent 28 units in length, another tangent 45 units in length, and the fourth tangent x units in length, and we have to find the length x. So what we are given in Math Challenge 400, we are given a rectangle and a circle randomly placed inside it. Tangents are drawn from the vertices of the rectangle. Three of the tangents, the lengths are given 23, 28, 45, and we have to find the length of the fourth tangent. Time is 5 seconds. So let's break down big problems step by step and crack complex math with simple logic in Math Challenge 400. Now we will prove it that x square plus 23 square, that is the opposite tangents, x and 23, x square plus 23 square is equal to the other two tangents, 28 square plus 45 square. X is a tangent and opposite we have got 23, that's the length of the tangent, so x square plus 23 square, and the other two tangents 28 and 45, 28 square plus 45 square, this should be equal. So we will prove it, but if we take it for the time being as true, then x square plus 23 square is equal to 28 square plus 45 square, that is x square plus 529 is 784 plus 2025. So x square gives 784 plus 2025 minus 529, that is x square equal to 2280. So x is the square root of 2280, which is about 47.75 units. So 47.75 units is the length of the tangent, that is the value of x. But we assume that x square plus 23 square, the tangents on the opposite corners, equal to 28 square plus 45 square, the other two tangents from the opposite corners. Now we will prove this to be true, although we have got the answer. We have got the answer, but this is what we are assuming. So we will prove it to be true in the subsequent slides. So what we do is join the vertices A, B, C, D of the rectangle to the center O of the circle. You can see the lines blinking, the red lines blinking from the four corners, from the four vertices A, B, C, D. We are joining the center of the circle. So we get AO, BO, CO, DO. These are lines from the four vertices to the center of the circle. So draw these lines from the center of the circle to each of the vertices of the rectangle. We get AO, BO, CO, DO. Now let us proceed further. From the center O, center of the circle O, we are drawing four radii. OP is a radius, OQ is a radius, OR is a radius, and OS is a radius. So AP, BQ, CR, and DS form the tangents, and OP, OQ, OR, OS, these are the four radii, and we know that radius is perpendicular to the tangent. So from center O of the circle, we draw four radii. OP is one radius, OQ is another radius, OR is the third radius, and OS is the fourth radius. We are drawing the radii perpendicular to the tangents. AP, BQ, CR and DS. So we have got the 4 radii, see the blinking blue lines. Now we know that radius is always perpendicular to the tangent. So radius OP is perpendicular to tangent AP. Radius OQ is perpendicular to tangent BQ. Radius OR is perpendicular to tangent CR, and radius OS is perpendicular to tangent DS. So all are perpendicular. So what we have is the given lines, that is the tangents AP, BQ, CR, DS. These are the base. Each of them forms the base of the respective right triangles. The altitudes OP, OQ, OR, OS in each case is R, that is radius, and AO, BO, CO and DO, they form the respective hypotenuse of the right angle triangle. So we have in each triangle, the tangent is the base, the radius is the altitude, and the line joining the vertex and the center, that is the hypotenuse. So in the first triangle, AP is the base, OP is the altitude, and AO is the hypotenuse. Similarly, for the second triangle, the line BQ, the tangent BQ is the base, OQ is the altitude, and BO is the hypotenuse. For the third triangle, CR, the tangent CR is the base, OR is the altitude, and OC is the hypotenuse. And similarly, for the fourth one, DS base, OS radius, that is altitude, and DO, that forms the hypotenuse. So 4 right angle triangles where the base will be the tangents and the altitude will be the radius in each case. So OP is equal to OQ equal to OR equal to OS, that is the radius, and the tangents are bases, and the line joining the vertex and the center in each case is the hypotenuse. So using Pythagoras rule, hypotenuse AO square will be equal to base AP square plus altitude OP square, that is AP square plus R square. Similarly, BO square will be BQ square plus R square, CO square will be CR square plus R square, DO square will be DS square plus R square. In each case, AO, BO, CO, DO, that's the hypotenuse. So the square of the hypotenuse will be equal to the square of the base, AP square or BQ square or CR square or DS square, plus the altitude square, that is radius square. So we get AO square equal to AP square plus R square, BO square equal to BQ square plus R square, CO square equal to CR square plus R square, DO square equal to DS square plus R square. Using Pythagoras rule, hypotenuse square is equal to base square plus altitude square, the altitude being R in each case and the base being the respective tangents given. So we got hypotenuse AO square equal to base AP square plus R square, and hypotenuse CO square equal to base CR square plus R square. And on the right side, similarly, BO square is BQ square plus R square, DO square is DS square plus R square. Base is the tangent and the hypotenuse is a line joining the vertex and the center, and altitude is the radius. So adding AO square and CO square, we get AP square plus CR square plus 2R square, and adding BO square plus DO square, we get BO square plus DO square is equal to BQ square plus DS square plus twice R square. Now we know that AO square plus CO square is equal to BO square plus DO square for any point O within the rectangle ABCD. If you take any random point O within rectangle ABCD, then AO square plus CO square should be equal to BO square plus DO square. If you want the proof of this, see our previous video, Math Challenge 399. This is Math Challenge 400. So the previous video, Math Challenge 399, gives you the proof of this. AO square plus CO square equal to BO square plus DO square for any random point inside a rectangle. You will get the proof in Math Challenge 399. The video link is given in the description box. So AO square plus CO square is equal to BO square plus DO square. Now AO square plus CO square, you put the value obtained above, AP square plus CR square plus 2R square. Similarly, for BO square plus DO square, put this value, BQ square plus DS square plus twice R square. So 2R square will cancel out from right side and left side, and you will get AP square plus CR square equal to BQ square plus DS square. So you get AP square plus CR square equal to BQ square plus DS square. This depends on this relation, AO square plus CO square equal to BO square plus DO square, and this relation, if you want the proof, see the Math Challenge 399 video. The video link is given in the description box. Now putting the values and cancelling out 2R square from both sides, we get AP square plus CR square equal to BQ square plus DS square. So we get, using that relationship, 23 square plus x square is 28 square plus 45 square, and simplifying, we get x square equal to 2280, x equal to square root of 2280 or 47.75. So we have to remember, even for tangents, AP square plus CR square is equal to DS square plus BQ square. And if you directly join the vertices to the center, then also you will get AO square plus CO square is equal to BO square plus DO square. So both for tangent, 4 tangents from the corners of the rectangle, and for the lines joining the vertices to the center, the relation is true. So AO square plus CO square is equal to BO square plus DO square. Also, if you draw the tangents, AP square plus CR square equal to BQ square plus DS square. So 23 square plus x square is 28 square plus 45 square, and simplifying, we are getting x equal to 47.75 units. That is the value of the length x.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.